So I know we went left 4. For the graphs, we're going to have a lot of fractions and decimals, so definitely it's not something you're going to necessarily do by hand. We're going to use Desmos to help us graph it. So when I look at Desmos, I'm going to type in my function, which is log base 2 of x. And we get our lovely graph over there. If I want to get some points for my graph or see if there's any good ones, I can press the wheel and then convert to table. So I see here, this is all undefined. That means I'm going to have a domain restriction. So I have 1, 0 as a good point, and then 2, 1 is a good point. Let's see, probably 4, 2 would be another good point. We're going to have a vertical asymptote at x equals 0, and we kind of know that because that's where our undefined is. So our domain is going to be x such as x is greater than 0. We have a domain restriction. Our range, we can go down forever, we can go up forever. It's going to be f of x such as f of x is an element of all the real numbers. X-intercept here is 1, 0. We don't have a y-intercept here because our vertical asymptote is on the y-axis. I'm increasing not for forever, but from 0 to infinity. So I'm starting super close to 0, and I'm increasing for infinity. I'm not decreasing at all. My horizontal, I don't have a horizontal asymptote. I can go up forever, I can go down forever. However, I do have a vertical asymptote at 0. So that's going to be x equals 0. For my end behavior for this left arrow, x is approaching 0 because I'm getting closer and closer to 0. But f of x is going down, so it's approaching negative infinity. For the right arrow, x approaches infinity, and f of x also approaches infinity because I'm going right and up. So it's going to be one of the very few times where we don't have a negative infinity and positive infinity for our end behavior. It's going to look a little different. So we're going to try that again. This one's log base 3 of x plus 1. So that means that I'm going left 1 with everything. You can kind of see how that makes our graph move a little bit. Just change how it looked in Desmos. So I can see that negative 1 is where it starts being undefined. So I have a point at 0, 0 this time. And then 2, 1 is another point. And I have that vertical asymptote at negative 1 because I moved the whole graph left 1. So my vertical asymptote also moved, just like in rationals. So for my domain, x is going to be greater than negative 1. My range, I go down up forever, so f of x is an element of all the real numbers. My x-intercept is 0, 0 here, and that's also my y-intercept. The increasing, I'm starting super close to negative 1, and I'm continuing forever, and I don't have a decrease. Horizontal asymptote, we don't have any. Our vertical is x equals negative 1. My end behavior as x approaches my left arrow is getting closer to negative 1. F of x is going to approach negative infinity because I'm going down. And for the right arrow, as x approaches positive infinity, if I'm going right, f of x approaches positive infinity because I'm going up.